External rating engines constantly stream millions of raw, disjointed transaction records into the SAP convergent invoicing data pipeline. When this influx is mismanaged, the system reacts poorly. One common symptom is generating thousands of fragmented, separate invoices for a single customer account, burying the client in unnecessary paperwork. The opposite extreme is equally disruptive. A poorly configured system outputs a single monolithic invoice, bloated with tens of thousands of microscopic, unreadable line items that make reconciliation impossible. These erratic outputs follow a specific breakdown in the configuration of the data transformation pipeline. The convergent invoicing billing execution operates through a strict two-tiered transformation process. To control the data, we must recognize the core architectural boundary. Mechanics operate either at the outer document level or at the internal item level. Grouping is the structural mechanism that controls the creation of the outer box itself. It determines the hard boundaries of the document. Aggregation, conversely, is the consolidation mechanism. It strictly controls and compresses the rows inside that box without altering the outer boundaries. Conflating these two distinct mechanisms causes standard billing bottlenecks. Using a splitting tool to summarize or a summarizing tool to split fractures the data pipeline. The billing process begins with an input phase. Here, raw billable items, those carrying a status of 0 to 2, are selected for the billing run. Before any custom logic applies, SAP executes a hard-coded default grouping behavior. This baseline evaluates 3 specific fields on every single item: the business partner, the contract account, and the billing subprocess. The system begins by partitioning selected items based on exact matches across these 3 fields. As the evaluation completes, the raw data physically separates into distinct clusters. Every item within a single cluster now shares an identical business partner, contract account, and subprocess. System consultants cannot bypass this mandatory partition. It mathematically guarantees that transaction data from 2 different customers never cross-contaminates a single invoice. This default partition often requires further refinement. Consider a business scenario where a single customer demands their data usage be billed entirely separately from their voice fees. To force this document-level split, we introduce the primary configuration tool, the grouping variant. The grouping variant evaluates characteristic values to dictate architectural splits. Here, the system evaluates the billable item type. By assigning values like DAT1 for data and TEL1 for telecom, the billing process physically partitions those item types from each other. The system output of this precise split creates distinct entities known as billing units. The partitioned clusters are locked into separate groupings. This establishes a fixed correlation. One generated billing unit results in exactly one final billing document. Therefore, if an architect needs to dictate how many separate invoices a single customer ultimately receives, configuring a grouping variant is the only mathematically correct approach. We now zoom entirely into the internal contents of a newly formed billing unit. Inside, items remain in their raw state, carrying highly granular transaction data detailing every micro-usage event. This would look chaotic on a final printed invoice. To solve this specific item-level problem, we deploy a different configuration tool, the aggregation variant. This variant acts exclusively as the internal consolidation engine. It operates completely independently of the grouping logic that built the outer unit. The granularity of this linkage is defined in SAP Customizing, targeting posting area 8115. Configurations here range from a straight one-to-one pass-through to a blanket n-to-one summarization, rolling up rows based on identical mapping parameters. When this n-to-one rule executes on the raw data, the granular transaction rows compress down into cleanly summarized billing document items. Notice the structural integrity here. This heavy data consolidation occurred entirely internally, without generating any new invoices. The outer box remained untouched. If the goal is to make line items readable and neatly summarized on a single document, an aggregation variant is the only correct configuration lever to pull. The pipeline reaches its conclusion in the final execution phase, where the billing process prepares to write the structured results directly to the database. We can now observe the dual mechanisms side by side. On the left, grouping handles the macro structure, splitting the stream into separate document boxes. On the right, aggregation handles the microstructure, compressing rows within those boxes. The system finalizes the run by executing the database commit. It writes the new billing document headers generated by the grouping phase, along with the summarized billing document items generated by the aggregation phase. Simultaneously, the system performs a critical cleanup action. The original raw removes the original raw items. The logic separating grouping and aggregation must be validated prior to execution. With the database commit complete, these newly structured billing documents advance to the final stage of the pipeline. These structured documents now move into the final invoicing phase, providing the stable foundation for tax calculation and printing. This subsequent invoicing process applies the final tax calculations and formats the final print layouts. However, its success relies entirely on the structural integrity established earlier. Mastering this strict two-tiered data architecture ensures that millions of raw consumption points accurately translate into readable, reliable revenue generation.